Hi, everybody. Here we go with the new unit, Unit 7, Lesson 1. We're going to start out pretty easy, hopefully, for most of you. We're going to be naming polynomials here. So let's just jump right in. Learning targets for this lesson, being able to name polynomials by degree and number of terms, and then putting a polynomial in standard form. So polynomial, you've seen it. That's the name of the unit. Let's talk about that first. The prefix poly means many. And nomial means name or term. So polynomial, put it together, you get many names or many terms, because we're going to use terms a lot in this lesson. I'll just say many terms. Terms then are basically just algebraic expressions separated by addition or subtraction. So you see an example here. This is a polynomial, x squared plus 4x plus 5. So x squared is a term, 4x is a term, 5 is a term. So that one has 3 terms. Another example of a polynomial is just 3x to the 4th. Okay, that's got one term. There's no plus, there's no minus. It's just one term. Another one, I don't know, 5x to the 6th minus 2. Right, that's another term. Or sorry, another polynomial. It's got 2 terms, right? 1, 2. So we're going to be talking about number of terms and classifying them based on number of terms next. I'm going to clear all that and scroll down. Okay. What do the following polynomials have in common? So these 4 right here, what do they have in common? Well, hopefully you see that they all have 2 terms. Kind of jumping around here on the notes a little bit, but they all have 2 terms, right? Because they have 2 terms, they are called binomials. Okay, bi, prefix bi means 2, so 2 terms. Okay, what do the following polynomials in number 2 have in common? Probably guess that they all have the same number of terms, and in this case, they all have 3 terms. You might even be able to think of the name using prefixes. These are all called trinomials. Tri meaning 3. Last one here, number 3, what do the following have in common? They all have 1 term, right? There's no plus, no minus. It's 1 term. So 1 term, these are called monomials. Monomials. Okay, 1 term. The number of terms is how we classified 1 through 3. So number of terms. That's how we classified those. You're going to need to know those names. So binomials, trinomials, monomials. We're going to stick with those 3. We could go further and have 4 terms, 5 terms. They could go on forever if you wanted, but we're going to focus on those 3. We're not going to get any bigger than that. And if we do, we would just say 4 terms, 5 terms. We're not going to worry about the names of those. Okay. There's another way to classify, though, that's a little bit trickier for most people. And we'll look at some commonalities here first before I give you those names. So what do these have in common? Well, they're not number of terms. You can see 8x minus 5 has 2 terms, and the next one, 6z, has 1 term, and then 2 terms, and then 1 term. Okay. These have in common that the largest exponent on a variable, and that is a key, it's the largest exponent on a variable, is 1, right? 8x to the 1st, 6z to the 1st, 9b to the 1st, 2/3 k to the 1st. If the largest exponent on a variable is 1, we call that linear. Okay. Number 5, largest exponent on a variable on these is 2. What do we call that? Can be a little confusing here. A lot of people think quad means 4, but this is actually a quadratic. I guess these are called quadratics because the largest exponent on a variable is 2. Okay. Next one is largest exponent on a variable is 3, right? So we call that cubic. And then the last one, there's no variable at all, right? So if there's no variable at all, the largest exponent on a variable is actually 0, right? There's no variable, so the exponent on the variable is 0. We call these constants. Okay. So that is the second way to classify. Scroll down here real quick, clear all that out of there. All of the polynomials in 4 through 7 are classified by degree. That was in the learning target. You probably didn't see it. I read it, but probably didn't make much sense at that point. Might not still make sense, but what I did there, linear, quadratic, cubic, and constant, those are by degree. A degree is the polynomial's largest exponent on a variable. Okay, so name each polynomial by degree and number of terms. So just a couple examples of what we just did, giving you a shot at practicing it. So number 1 there, 5x squared plus 4x minus 8. The degree, that's what the D stands for. Degree is the largest exponent of a variable. It's 2, so the degree name would be quadratic. How many terms does this one have? It's got 3 terms, right? 5x squared is 1, 4x is another, and then 8 is the third. So the number of terms here is, the name would be trinomial. Number 2, 9x, the largest exponent on a variable is 1. So this is linear. The number of terms, there's only 1, so this is a monomial. So what you'll hear me say sometimes is, give me a linear monomial. That would be an example of that. Or a quadratic trinomial. That's like number 1. Okay, number 3. A lot of people get confused here because they look at it and say, oh, 2, exponent of 2. Careful, look at the whole thing. The exponent of 3 is here. This is a cubic. There's 2 terms, so it's a binomial. Okay. Now, that idea that I just talked about on number 3, got to be careful with that. We can take care of that. And that's taken care of by standard form. To write a polynomial in standard form, you write the terms in order from largest exponent to smallest exponent. That's going to be in standard form. You're going to be expected to write them in standard form. Another thing about standard form is you must combine like terms. Like terms have the same exponent and same base, but can have different coefficients. Now, what do I mean by that? So I'll give you a couple examples. 2x to the third plus 3x to the third. Those are like terms. The bases of x are the same. The exponents are the same. Okay, so those are like terms. I could put those together and actually make 5x to the third. An example of non-like terms that a lot of people get confused by is something like this. 2x to the third plus 3x to the second. Those are not like terms. Yes, they have the same base, but they do not have the same exponent. I cannot put those together. Okay, so a couple examples down there with standard form. So number 1, 5x squared minus 2x to the third. Not in standard form because it's not going in order from largest exponent to smallest. So I'm going to put them in order. Now the sign stays with the term that it goes with. So that negative actually goes with the 2x to the third. So I'm going to take that to the front. So it's going to be negative 2x to the third. And then the sign in front of 5x squared is positive. So it's plus 5x squared. I cannot combine that because the x's, yes, they're both x's, but one's got an exponent of 3. The other one's got an exponent of 2. Can't put those together. So the degree on this one, biggest exponent is 3. So I can say cubic. And it's got 2 terms, so it's a binomial. Number 2, What I like to do is underline or circle my like terms. There's no other x or z squared here, but I do have two z's, right, that I can put together. So standard form, I still have to write the z squared first. So that's 7z squared goes first. But I can put 4z plus 3z together and make 7z. Notice the exponent does not change. Z plus z is just 2z, or 4z plus 3z is just 7z. And then finish it up with minus 5. Biggest exponent is 2, so this is quadratic. And it's got 3 terms, so it's a trinomial. Last one, nice long one there. 8p to the third. And there's another one, so I'm gonna underline those. I got a negative 3p, I'm gonna circle that and circle that. Make sure the symbols are the same. So if I underline the p to the thirds, I'm gonna do something different with the p's. Well, 8p to the third and negative 8p to the third makes 0p to the thirds. So those actually just cancel out. Negative 3p and 3p also cancel out. And all I'm left with is 7. So in standard form, this one is 7. The degree on this one, there's no variable, so it's a constant. And there's only one term, so it is a monomial. Okay, next lesson, we're going to be adding and subtracting, kind of what we just did there at the end, but we're going to do more of it with the next lesson. After that, it's going to get a little trickier, but this is the basics. Make sure you understood this. Let me know if you have any questions in class, and we'll get this figured out.